Um, Hello, everyone. Welcome back to the final week of the LLM Bootcamp. In the previous module, we had Ravi Theja who covered the basics of components of how the Llama index is used, including the knowledge bases, the query engine, and the indexes. In today's session, we will cover the module 13, which is on retrieval augmented generation using Llama index. We have with us Ravi Theja again, who is a data scientist at Glance and open source contributor at LLamaIndex and one of the top 5 Gen AI scientists award winner by Analytics Vidya. And we will start with where we left off from the last week. And based on your feedback, I request Ravi to showcase the Open LLM notebook as per the audience request. Yeah, thanks, Ravi. I'll hand it over to you.
Yeah, cool. Thank you, everyone. Thank you, Rohan and Tarun as well, who is not here for coordinating with you and making this session happen. Let me share the screen. I hope it is visible. Rohan, can you confirm? Am I audible?
Uh, yes, you're audible and it's visible. Yeah.
Okay. Thank you. Sure. So, yeah. So to give a brief introduction about myself, I'm Ravi Theja, data scientist at Glance and also contributor at LLamaIndex for past few months. So in the last session, we discussed about LLamaIndex, why, what they started with, what brief context about LLMs, brief use cases about LLMs, and then context why where we are heading towards, how we want to augment private data with LLM, what are the different paradigms like fine tuning paradigm, what is the obstacles, downsides with it, and then what is other paradigm in context learning, what are the upsides and downsides with it, and overall in general, what is challenges we face with in context learning. And then we then figured out, okay, Llama Index is a centralized framework between LLMs and these data sources. And then we saw what is retrieval augmented generation framework, and then we went through different components of Llama Index like data ingestion, indices, and retrieval and query interface, right? And then yeah, we went through each of these abstractions. We introduced vector store index and retrieval as well. What is retrieval? What is vector store index? And how response instance works? How all these query engine helps query the index, retrieve some things, and generate a response. We took some interesting use case like semantic search or building QA system, and then building a summary of a document, and as well a route between two different indices for two different queries. And then we went for sub question query engine where it creates a query plan between two indices when you want to compare two different documents. And then we went through how to query documents which contain both text and table as well. We even went through text to SQL use case, right? And uh, joining text to SQL and semantic search, text to SQL and RAG. And then we add up with some interesting applications with using Llama Index. And yeah, that's what overall we have seen about Llama Index. So in this session, I'll go through whatever we have discussed. We will go through implementation using Llama Index, the RAG system, building a QA system, adding and one of the most interesting thing that everyone was asking, how do you build this QA system with open source LLM as well? So how do do that? So all these things we'll be covering. But before that, I just want to have a quick understanding. Like, do you need me to um, go through some basics of components of Llama Index once again as a recap, or just right away with uh, go with the notebook part? If you can give me some feedback on that end, it will be very good. I'll take a minute pause here. If I get any comments on the 10, I'll look into it. Okay, let me go with it. So we'll be using in the last session, whatever I said, we will be using some three documents for it: Uber and Lyft, and then we have Polygram essay as well. So, here are the different topics that we'll be covering in today's session. Uh, so this process. Okay, Harsha SR asked, I actually tried LlamaIndex notebook with OpenAI and it took time. Can't be slow this process. I don't know how long the document is, how many pages document is. So are you using vector store index or you are doing with some Pinecone or something? How did you do this? If you can give me more details, I can help you with that. But yeah, so here are the starting things with Llama Index. Experiment with LLMs, connect with an LLM. How can you connect with LLM with Llama Index? What are the data connectors? How Llama can be used? What are the core components of Llama Index? Build a simple QA system. Add more doc. How can okay? I had build a QA system with one single document. I want to add more documents. How can you do that? How can you customize different components that are available in Llama Index, LLMs, or embedding modules, or chunk size, and other things? And then we have seen some interesting applications of router engine and sub-question query engine as well that can route user queries to different indices. And then at the end we see how can you connect with open source LLMs as well, right? Okay, cool. So yeah, so for this, we need an OpenAI. For the first part, we need an OpenAI key. I hope it is visible. Just give me some uh, response in the chat so that it is useful for me to go ahead, or else I'll be zooming in. Okay, let me go with it. So we need OpenAI key or any other LLM. So here I'm choosing OpenAI GPT-3 LLM here. So yeah, I got this from OpenAI. All you have to do is go to OpenAI Playground and then OpenAI keys here and then create a new key here and then get a secret key, whatever it is, and then you can just paste it out here. Okay, let's keep this in a variable. Cool. And then I have some chat message. I just say that system you are an AI resident user, and I just asked what is the revenue of Uber in 2021, and then let's see what it answers. Okay, it said that as an AI, I don't have real-time data access. However, as of my, Uber has not released its revenue figures for the year 2021 yet. It is best to refer to official source of finance reports or something. So basically, it doesn't have information about revenue of Uber in 2021. So since it doesn't have an information about Uber in 2021, let's connect actually Uber 2021 financial filings and ask the same question again. So how will Llama Index help there? So first thing we have to do is we need to load the data. So I have uploaded here over 2021 financial filings. So and then so now I use, as I said, we have Llama Hub where there are 100 plus data loaders, and you can use one of these data loaders to load the document. So since it's a PDF file, we'll use a simple directory and directory reader, which automatically detects. We'll use a PDF reader module reader loader, and then loads the document over 2021 filings. So it's just browsing, and yeah, it's done. So let's look at how many. So each page will documents of, let's say, 0. So it has page label, file name, and then all the text data present in it, right, for the first page. So I think there are 200 pages or 300 pages in it. So let's check how many document objects are present in it. So there are 307 document objects. Since there are 307 pages, each page will be one document here. So that's how we'll have 306. Yeah, this is the last page of the document. So yeah, once you have loaded the document now all you have to go through is what are the core components of LLamaIndex. As we have seen, we load the documents, we index over the data, we have a retriever, we have a query engine. So index is like a library of your data which stores your data. Retriever is a librarian that finds relevant data for you. And then response insert is the storyteller that creates a response. And query engine is like the director which coordinates with all these different modules and create a final response. So we will okay, yeah. So we'll pass the given document and get a nodes from it, and then we'll use vector store index for it. So simple node parser from default will is a parser inside llama index which will convert your documents into nodes. So we'll get nodes from given document, and then we'll index it. We'll make index act as a query engine, and then now again we'll ask what is the revenue of Uber in 2020. Let's see if it's able to answer the question. It might take some time for first time building an index. So because you have to create embeddings as well, and nodes for each embedding for each node chunk as well. So going after this, what we will see is, yeah, okay, fine, cool. So it has given an answer. The response revenue of Uber in 2021 is 17.455 billion, or 17.455 million as well. So here, as you can see, you asked some question about Uber and directly to LLM, because if it's not its gap, it couldn't answer. But when we attach the right document to LLM, and by retrieving the right context, it is able to give a correct answer, which is useful for us, right? So that's how. So all probably just 5 lines of code, simple code, you're able to build your QA system. So someone is asking that it is not working well fastly. So if you have seen here, it is pretty fast in front of you. I just it, even let me run this just only the query engine part again. So it's pretty amazingly fast to generate an answer. So yeah, that's how you will build a basic QA system. And then, okay, I have built one document. Now I want to add one more document to it. How can I do that? So we'll use a simple directory reader just to load the document. It's a TXT format file. Either we can use a reader like PDF reader, like text reader as well, or else you can just use simple directory reader, wherein it can automatically handle the based on the extension which reader to use for some basic extensions like PDF, text, audio, video files. It will work. So we'll read the documents, and then since it has there are no pages into it, I think let's check times. There's only one document because I have dumped entire thing in one full page like this. So yeah, so we'll use this document to make some things here. So now we'll again, these are new nodes. Let's create nodes from the given document, and then whatever index we have prepared, we'll insert this new nodes index dot new nodes, and then create a query engine from the new index from the same index, and then we'll ask the question regarding this document, which is polygram essay document. So polygram is a founder of YC. So yeah, so it gave Polygram started YC because he found about anything something related to why he started YC, right? So in this way, even though if you sorry, I got some question here. Can you please walk through the query engine workflow? Okay, cool. So what happens is when a query engine is called, so when you query once your index is formed and your query engine, if you view your, so there are three basically three ways. Once you build an index, there are three ways you can use that index. One is query engine, other is chat engine or agent. Query engine is you ask some question, it will generate an answer. Chat engine is it's like a chatbot. You ask some question, it gives an answer, and the next follow-up question, it will even take the context of the previous question asked or the response it created, so that it will remember the previous conversation that you had with it. So it's like a chat interface, and then there is a agent which is acts it does some tasks. So that also, or it can even act as a QA engine as well, right? So that's how there are three formats. So when a user asks, so I'll just concentrate on the query engine part here. So when a user asks some query, what query engine does is it hits the index with the help of retriever. It will retrieve some specific node, like top k equal to 1 or 2. I did not keep any top k, but you can keep similarity top k equal to 2 or 3, where based on your similarity, embedding similarity, it will retrieve 2 or 3 nodes. And then once these nodes have come, we'll send these to responses model. So earlier we have seen that in the response, we'll send the retrieve nodes to response instance module. In the response instance module, given a query and node one information, both will be sent to LLM, and an internet answer will be generated. And then again, internet answer along with node 2 query along send it to LLM, and the final answer is generated. So this is how a response instance model along with the return nodes functions. So that's how the query engine works. I hope you got some little understanding about it. So yeah, so we have seen till now we have seen given a document, index it, build a query engine on top of it, and create a response. And then on top of that, if you want to index, add one more document to it, to the already built index, we have created nodes from new document and then added them to the existing index and build a query engine and start creating a response for it. Cool, that's fine. But again, I want to have some specific uh, control over what is LLM I want to use, or maybe what is the embedding model I want to use. I want to change the chunk limit, chunk size for each node. What is the chunk overlap between the nodes? So in those cases, how can you do that? So for that, all you have service context, LLM predictor, opening, embedding, prompt helper, and all those things functionalities in LlamaIndex. So what it does is, so we first create an LLM. What is LLM? So here it's open an LLM. You can use other LLM like Power AI or Light LLM or any other way, and then use this uh, abstraction with model name GP3.5 turbo, temperature 0, max tokens as output tokens as 2 6. And then you can even initialize an embedding model, open an embedding model. And you have a node parser from document defaults with I kept a default chunk size as 2000. tokens with chunk overlap are 50 tokens. So what does chunk overlap mean here? So as we have seen, we have created node 1 and node 2, right? So I have in node 1 I'll get 2000 tokens, first 2000 tokens. In node 2, the second 2000 tokens. But since when generating an answer, it would be useful to have a context of previous node as well, right? So whatever last 50 or 100 tokens are there, it will be overlapped with the node 2 information as well. So there is some overlap of tokens between both of these nodes. So that is chunk overlap, which I give 50 tokens. And then there is prompt helper. What is the chunk overlap ratio during synthesis time, context window, and then what is the final output number of output tokens available. And then we have the service context, which the abstractions take care of what LLM we'll use, what is embedding model we'll use, and then what is a node parser, what is a prompt helper, final parameters, all these parameters. And then while building the index, we give service context as this, like use these LLM and embedding models for that, right? And then build a query engine as query engine and start querying it. As I said earlier, the default is just similarity of k is 1. Now here I have given to experiment with it, I have given similarity of k equal to 3. So now I have what did the author do growing up. So let's run this. So it is created an index and then it is trying to create an answer. So here it said the author worked on writing and programming outside of school before college. They wrote stories and something IBM something. So that's how you can even customize different embedding model or different LLM as well, uh, uh, and then create an index and query engine, and you can make similar to things and then generate an answer. So yeah, I have a question. If my understanding is correct, document and node are same. So yeah, one question is for loaders, are we using Llama Hub or Llama Index? So Llama Hub is part of Llama Index only. They're not different. So since to make things easy, we had created Llama Hub where there are all the load data loaders available, and it will Llama Index uses that Llama Hub, which is part of Llama Index only, to connect the documents. And then one more question is, if my understanding is correct, document and node are same. No, document and node are not same, since because um, document is you have one, like here Paul Gromez says this is one full text here, and then this is one full document, right? But what is node? Given a document, you will be creating these chunks based on, so I have given a parameter here, right? What is the chunk size? So the same thing will be used. So the first 2000 tokens here, the chunk size is 2000. So first 2000 tokens will be in node 1. So whatever information is there, you take this thing and take first 2000 tokens from here and put it into node 1 and create embedding also for it. In node 2, next 2000 tokens, node 3, next 2000 tokens. So that's how you create from a given document, you create all these nodes, right? Okay. I hope it is clear. And then now, okay, till now what we have built is we have created a QA system, basic QA system, by creating nodes and creating index and query engine and response instances. And then if you want to customize any LLM with it or embedding model, and then chunk sizes and number of outputs and all those things, we have created that as well. And then created a QA system on top of that. But then again, um, uh, in the same context only, what is chunk ratio? So chunk ratio is number of. I think I'll cover that towards the next part of the session. So please hold back for that. So yeah, and then we have retriever and response synthesizer for it. So So we want to customize even retriever, and then there are different modes in synthesizer as well. So how do you customize them in the using llama index? So one thing is, we have, since we are using vector store index, we use vector store index retriever, and then pass whatever index we have created, and similarity dot k equal to 3. And then we have synthesizer get a response, and there are different synthesizer modules as well. You can check in the documentation for that. And then response mode, with response mode accumulate. The usual one is okay. Let's start with refine probably, and then ask the question, what information do you have? So once these two are defined, you can have retriever query engine with retriever and response inside it, and then create a query engine on top of it, right? So let's do that. Let's create ask a response. What information do you have about Zomato investment? Oh, I couldn't even get it. One second, let me check. Source. So if you see the source information, it actually did not retrieve anything about Zomato. So that's the reason it said I don't have anything related to Zomato. Yeah, cool. So, and you can use any other response mode here, like you have let me check, accumulate as well, which response modes. Yeah, so there is refine, whatever we have seen, and then there is compact. So concatenate all the chunks beforehand before sending it to LLM. And then there is the tree summarize, which will be useful for mostly for summarization purposes. And then there is accumulate as well. So since we have taken top three chunks, will be for each chunk create an answer for it. So these are different modules that you can look into, response modes that you can look into, and then create an answer for it. Okay, and then okay, now going forward, node post processor. So once we retrieve the retriever because of retriever based on embedding similarity, let's say top three or top four, but then still, even after retrieving that, I want to filter out the nodes. Let's say based on if the filtered nodes has some specific keywords, or maybe if the filtered nodes has similarity score of more than zero point 0.5 or zero point 0.9 zero point 0.8 or whatever similarity score you want, or maybe you want to do some post processing and then filter those nodes specifically. So in all these things, yeah, so we create a node post processor and then pass that node post processor into the abstraction. So here I have a similarity post processor with similarity cutoff as 0.98, and then I define a query engine on top of it, and have and create the same question again. Empty response, because there are no nodes which have a similarity cutoff of 0.98, right? So because of that, there is no response in it. I hope you all understood till this point. Any doubts till this section before going forward? Okay, cool. So let's go with router engine. Just want to give a small recap about the router engine part. So yeah, so we have vector store index and list index or summary index, and then which is some for summarization purposes, and then this is for answering specific questions from a index, right? So for the user query can be either related to summary or maybe related to specific context, like what is the revenue of Uber in 2021. So how can you answer that? So how can you route given user query to one of these indices? So that's how that's where router engine will be helpful. So for that, yeah, to create a summary index on the polygram essay, we created summary index as well as vector index. So let's run that. And then, as I said earlier, there is one response mode as tree summarize. So I have used that mode since because this is query engine is rated for summarization purposes. And then after that, you create tools for each of this. There is okay, so this should be actually summary tool. Summary query engine, which is useful for summarization purposes and then useful for retrieving specific context. You need to give a description for each of these tools. Then you run this, and then after that you plug in your router query engine with LLM single selector. So what this selector does is it uses this LLM single selector to choose one of these tools, either summary tool or vector tool. So yeah, so and then you create the query engine and then ask the question, what is the summary of the document? And let's see what it answers. And the next question we have is, what did polygram start? When did why did polygram start by C as well? So yeah, so it gave full summary. The document provides a personal account of the author generated from writing. So some things, and then also at Yahoo and some programming things. What are the different challenges he faced? And then it even answered why did polygram start by C. So in this case, it uses the vector store index and create an answer for it. So that's how for two different purposes we have two different indices and automatically it chooses one of it. And then we have a sub question query engine, um, which is yeah, this is a question query engine. And then you have a given query. I want to I just want to recap even sub question query engine as well. So you have two documents, Uber and Lyft, and then you have a given query, compare revenue growth of Uber and Lyft from 2020 to 2022. So in general, what you do as a human, first I'll get the revenue growth of Uber from 2020 to 2021, and then I'll get revenue of Lyft from to 2021, and then get individual answers. And now I'll combine both of these answers and create a final answer for it. So for that, there is to create automatically all this query plan, we have sub question query engine for it. So given a query, it will create these two queries. What is the revenue growth of Uber from 2020 to 2021? And then what is the revenue growth of Lyft from 2020 to 2021? And it will hit, so there is this index Uber 10K filing and then Lyft 10K filing, which is, this is the same. This will hit this Uber 10K filing index and generate an answer. And this will hit Lyft 10K filings index and generate an answer. And then now you have these two answers. So the query is compare revenue growth of Uber and Lyft. So it compares and collates and gives a final answer. That revenue growth of Uber from 2021 is higher X% and all. So that's what it is. So let's read these files first: Lyft documents and Lyft documents and the Uber documents. So do we use? There is a question: do we use semantic search for document comparisons? I did not understand what is semantic search for document comparisons. I couldn't get what you are trying to ask. So it has read the documents. Now I create. Earlier we have seen creating indices from nodes, right? So if you don't want to play with the nodes, I want to directly create indices from the documents. You can do that as well. So that's how I have shown here. Vector store index from documents. We just use whatever documents is there here and over documents as well. You can still create nodes and on top of that create indices as well. There is no harm in it. But yeah, but here I'm using Lyft index and Uber index, creating both these indices for subquotient query engine purposes. Um, it might take semantic or similarity search as similar to vector DB. Um, really sorry, but I couldn't follow your question. You asked, do we use semantic search for document comparisons? Yeah, I'm creating. So, if you mean I create two indices for two different documents, and then let me go through it so that you'll understand it. Now we have two. I created two separate indices or query engines for it. Now let's start with asking querying both of these indices. What is the revenue of Lyft in 2021? What is the revenue of Uber in 2021? Okay, and then now you can use these two query engines individually to perform a semantic search or QA system, or else, and then but you want to do a document comparison. Now I'll make tools out of it: query engine tool for Lyft query engine, and then Uber query engine as well, and provide the specific description of what the document provides information about Lyft financial for the year 2021, provide information about Uber financial for the year 2021 as well. So, and then we create subquotient query engine from defaults. This will create a query engine from these two tools, so it has access to both of these tools now. Okay, and then we create. Now we pose a question. Say, so let's see what it answers. So as you can see, oh, something missed. One second. Is it visible now? Sorry, some I think by mistake I pressed um, something earlier. Okay, cool. So as I said, I asked this compare revenue growth of Uber and Lyft from 2020 to 2021. So here, so internally it created, so for sub questions, what is the revenue of Uber in 2020? What is the revenue of Uber in 2021? And then what is the revenue of Lyft in 2020 and what is the revenue of Lyft in 2021? And it got answers for all of these questions, right? What is a Lyft, Uber, and then all these things. And then finally, the revenue growth of Uber from this period was this, while the revenue of this is this much. So that's how there is the comparison between the documents is done. So individually, if you ask, okay, there is comparison of documents, but internally, is there some semantic search is happening backend? Yes, that is happening because each of these questions are posed to individual indices or query engines and generate an answer, right? So that's how you create. That's how internally that semantic search still happens. Okay, and then we reach the final part of the session, which is connecting with open source LLM. So there are many open source LLMs are available, but some of uh, um, as we hear with the experiments like Llama 2 70 billion is more uh, behavioral towards GPT 3.5. So we have, okay. So any scale actually provides endpoints for all these open source LLMs. So yeah, so they have different models, supported models like Llama 2, 7 billion chat, HF, or Llama 2, 13 billion chat, 34 billion, 70 billion. And so we have to, so we can use these open source LLMs from any scale and create some connectors for it. So for that, I created beforehand some get my API key as well. So I got my API key. So and then we have any scale abstraction. So I use 70 billion chat HF model with any scale endpoint token, and then I have this OpenAI embedding. Since we need LLM as well as embedding for generating for QA system, right? So here there is this, yeah. So there is LLM as well as we use Llama 2 LLM, but we use OpenAI embedding for embedding creating embeddings backend, and then we actually create this service context where we define what is LLM. We are using Llama 2 LLM here, and then what is the embedding we are using. So we have this service context. In the service context, we define that, and then we create a vector store index from that, and have a query engine for that, and we'll start asking why did polygon start by C. So let's do that. As simple as that. It's pretty fast, right? So let me do this here. So yeah, we have an answer. Partial strategy because he wanted to scale up startup funding, and what are the other reasons for having it. So you can use any other model available here, as we have seen. There are support from models that 7 billion as well, 13 billion as well. Let's start. Let's try with 7 billion once. So 7 billion, and then create the index again. Let's see how different the response will be with 7 billion now. So it did not actually perform well with 7 billion. So he was telling Poland did not directly refer to the given user, but he did provide some clues about he started. But yeah, overall started wise, it created it indeed gave an answer, but in a very different format from 70 billion form model to 7 billion. You can even try with 13 billion. Let's see how different it will be. And then see, based on the context, product platform, something. So it gave an answer. It gave some pretty good answer as well. So that's how you can see how different the responses were with 17 billion, 70 billion, and then 7 billion and 13 billion models are. In fact, there are many other data connectors available inside open source model connectors available inside LLamaIndex. One is this. Um, so LLMs, you can go modules, then check about there is Monster API. So like any scale, even Monster API also provides uh, Monster API provides endpoints for all these open source models. So here, if you go and check, there is Llama to 7 billion chat model as well. So you can go through this documentation how to use Monster API for open source LLM as well further. And then they only have 7 billion model, but any scale has all these different all the versions of Llama 2 model as of now. And then you can even use Hugging Face models as well. There is Hugging Face Stable LLM. You can use the Hugging Face LLM connector available, and use them and create a generator response accordingly. So um, so that's how you use these platforms like any scale, Hugging Face, or Monster API to um, and then use all these open source LLM who are hosting to give generate an answer. So, does any scale require OpenAI key? One of the questions. No, it doesn't require any scale. Any scale doesn't require OpenAI key. So, what any scale uses? So, go to any scale. All you need to do is register an account, generate an API key for that. You will should be able to. You need to um, give your billing details, add your card details to get this token. So once you have this token, you can just have this in an SQL endpoint. That's it. You just plug in this abstraction, whatever model available, whatever Llama 2 models are available, you can use them. And but since for embedding model you are using OpenAI embedding, for this you need OpenAI key. If instead you want to use, instead of OpenAI embedding, or you want to use some other open source embedding module like sentence transformers, we have connectors for that as well. So you can use them in the place of this. For that, you don't need OpenAI key. So you can use that open source sentence transformer model and use that as a embedding model and create the same end-to-end process. So that's how you can use, yeah, you can get away from OpenAI and then build a QA system like this. So yeah, that's what I have for this session. I hope you enjoyed an end-to-end walkthrough of LLamaIndex code, different section of it. Yeah, if you have any questions, I can ask it for 5 more minutes. Yeah. Okay, yeah, this question in the same context of chunks, what is chunk ratio? So, yeah, chunk ratio is what is a percentage of your nodes chunk size with respect to the output token. That's what the chunk size ratio here is.
We'll probably wait for a couple of minutes.
Sure, sure. Um, is using RAG a best practice? So for which use case, if you have a document and want to perform a QA system on top of that, yeah, it's a good practice to have that rather than you can even try fine tuning approach on your own document using GPT 3.5 or any other model and see if it is working, is able to yeah, I got it. So compared to fine tuning, you need to compare and then see which is performing better, either RAG or fine tuning, which is more cost efficient as well and accuracy efficient as well, and then see how good they are. Also, I think the previous question, yeah, you were asking about chunk overlap ratio, I guess, not just the chunk. Chunk overlap is the ratio of how much is how much is the overlap between based on the chunk size. That's what chunk overlap ratio is. Just want to convey repeatedly so that you understand it properly. Can join our Discord channel for any queries as well. We are pretty much active on our Discord channel. So you can find. Let me share screen once. So we'll have a lot of things on documentation as well. So you can get on. You can check our. Where is it? The Discord. Yeah, you can follow us on Twitter, or you can join our Discord community as well. If you have any questions to get the latest updates, you can go through our handle, LLamaIndex handle as well. We even open sourced one of the RAG platforms. So how can sorry, where is this? Okay. So second insights is there. So how can you product? People always say that, some people might face uh, an issue with productionizing this whatever you have built with LlamaIndex. So they have released an open source framework to help you with deploying the second insight, deploying the RAG system that you have built with LlamaIndex. So you can check with this project second insights in for that. Yeah, second insights.ai. I think if there are any more questions, maybe we can.
Yeah, sure. I think if there are no more questions, we'll wind it up. Thanks, Ravi Theja, for joining here and also giving us valuable information. And I hope people will be able to connect with you through Discord and Twitter, or if they have any doubts. And
Sure.
yeah, thanks everyone for joining, and hope you had a wonderful session. And have a nice weekend.
Thank you, everyone. Thanks, Rohan, for the opportunity. Thank you. Have a great weekend. Bye.